And then we're recording right now. Okay, so let's start off this lesson. This is box number 1. We're going to talk about what sequences are and how to define them, all right? So I'm going to begin just by giving you some numbers. But let me ask you real quickly, what is a sequence? If someone said, hey, what's a sequence, what would you say back?
It's a great question.
It's a great question, yeah. Yeah, Matt. Pattern of numbers, yeah, exactly. So let me give you a pattern of numbers. 1, 1, 2, 3, 5, 8, and then a dot, and then a dot, and then a dot. Okay, here, this is a sequence. It's a pattern of numbers, right? We may or may not be able to describe the pattern right now, but we're going to learn how to do that over the course of time. I want to talk to you about the structure of patterns, all right? First, the thing I want you to notice is this dot, dot, dot over here. What does this part mean, the dot, dot, dot? It keeps going on in the same order until you get to infinity, right? And where's infinity? Way out to the right somewhere, okay? Now, if your sequence happened to end, say, just for example, let's say it ended at 8, and I just gave you 1, 1, 2, 3, 5, 8, then we would call that a finite sequence, okay? So sequences that end are called finite. Sequences that don't are called infinite. So the difference between the two, all right? Now, the true definition for a sequence is actually a function. Who remembers what a function is from Algebra 1 or Algebra 2? Function. Does that word ring a bell to you? Yeah.
You put in one thing, you get out.
Perfect. You put in one thing, you get out another, right? So a sequence is really nothing more than a function, and the way that we describe them is by using subscripts. So I'm going to underline all of these for a reason here. I'm going to take that away for just a moment. Okay, the way that we describe each of these numbers that we're seeing, these are called terms of my sequence, okay? So this 1 represents the very first term, and the way that we represent a term in a sequence is with a subscript. So A sub 1 represents the first term. A sub 2 represents the second term. A sub 3 represents the third term. I bet you could guess what the next one's going to be. What's it going to be, everybody? A sub 4, no, Iman. A sub 5, what's the next one going to be? A sub 6. Okay, now if this kept going way over here, what would this one be? A sub, not the infinity, sorry. A sub, we call that A sub n, right? The nth term, okay? Okay, why do we call it this way? Well, now I can ask you questions. I could say, hey, everybody, what is the value of the fourth term? Then what would you say? You'd say 3. What's the value of the sixth term? You'd say 8. What's the value of the fifth term? 5. What's the value of the second term? No, 1, right? It's 1. What's the value of the first term? 1. Okay, good. So each of these items right here, right? These are called your terms. Each of those are called your terms. Okay? Now, this is a function because we are putting in inputs and outputs. Okay? The reason this is a function is because if I plug in a 1, the output will be a 1. If I plug in a 2, the output will also be a 1. If I plug in a 3, the output will be a 2. If I plug in a 4, the output will be a 3. Well, this one's not technically a function because of the 2 and the 1, but, or actually it is. If I plug in a 5, I get a 5. If I plug in a 6, I will pop out an 8. So these numbers that we're putting in, these little tiny subscripts, these are your domain values. These are your domain values, right? So when you think of functions, you think of inputs and you think of outputs, right? The inputs are all your x's, your outputs are all your y's. So in this case, the inputs are all the subscripts and the outputs are all the term values. Does that make sense so far? Okay, awesome. We're on the right track. Okay, the first thing that we learn how to do with sequences is to learn how to write them. So the book is going to give you a notation that looks like this, these little curly brackets. And whenever you see these curly brackets, it's a clue to you to let you know that we're talking about a sequence, all right? So we're going to define a sequence, A sub n, as being 3n plus 4. And the directions are asking us to write out the first 4 terms as defined by A sub n equals 3n plus 4. Okay, so what do they want you to do? Like, set yourself up for success, right? They want the first term, they want the second term, they want the third term, and they want the fourth term. So they want you to write the first 4 terms of the sequence. Okay, now remember I told you it was a function, right? how do we generate what the first term is? There has to be something that we do. There has to be an operation or something. Anybody see it? Yeah, what do you got? You got plug it into the n, right? Absolutely. Do you guys notice that this n and that n are the same n, right? Okay, so how would I generate the first term? I would simply say, okay, this is going to be 3 times 1 plus 4. How much is that worth? That's worth 7. So the first term of my sequence is 7. How do I get the second term? Nope. This would be 3 times 2 and then plus 4. How much is that worth? 6 and 4, how much is that worth? 10. So the second term is now 10. Okay? The third term is going to be 3 times 3 and then plus 4. 9 and 4, how much is that worth? 13. Very good. And then finally, the last term, I take 3 times 4 and then I add 4 to it. I get 12 and 4. How much is that worth? 16. So, ladies and gentlemen, the first 4 terms of the sequence, as defined by 3n plus 4, is nothing more than 7, 10, 13, and 16. Okay, another example here. It's a fraction. I have negative 1 to the nth, all over 2 to the n minus 1. Same directions. We want to write the first 4 terms of the sequence. So set yourself up for success. This is going to be a sub 1. This is going to be a sub 2. This is going to be a sub 3. And this is going to be a sub 4. Okay? How do I generate the first term? What do I do? Replace all the n's with the 1s. Very good. So this is going to be negative 1 to the first, all divided by 2 to the first, and then minus 1. So what's negative 1 to the first? No, try again. Negative 1. Good. Okay, what's 2 to the first? 2. 2 minus 1 is? So what's the very first term? Negative 1. Very good. Awesome. Let's move on to the second term. I want negative 1 to the n is now a value of 2, all divided by 2 squared minus 1. What's negative 1 all squared? Positive 1. Very good. That's worth 1. 2 squared is 4. 4 minus 1 is 3. So this is a third. So my next sequence, the next term of my sequence is a third. Notice it's a different sign. Huh. Okay, let's do the third term. Let's go negative 1 to the third, all divided by 2 cubed minus 1. Negative 1 to the third is going to be what? Negative 1. Very good. And then 2 cubed is how much? 8. 8 minus 1 is how much? 7. So it looks like my next term is negative 1/7. Okay, let's finish this off together. Let's go negative 1 to the fourth, all over 2 to the fourth minus 1. Negative 1 to the fourth is going to be what? Positive 1. 2 to the fourth is 16. Take away 1 is what? 15. Very good. So I get an answer of 1/15. So there is the first 4 terms of the sequence. And do you notice that this sequence alternates sign? One term is negative, the next one's positive, one's negative, one's positive, right? That's because the reason it alternates sign is because of that numerator, negative 1 to the n. All right, so a recursion formula, if you look in the book and you read the chapter in 10.1 about what a recursion formula is, it gives you this long, nasty mathematical definition. I prefer my own very simple definition of a recursion formula, and it's stated as the following, okay? A recursion formula is you must know the previous term in order to get the next one. Okay, now that's my very simplified version of what it means to be a recursive formula. You have to know the previous term in order to get the next term. So let me give you an example of this to illustrate the point, all right? I'm going to give you a sequence. I'm going to tell you that a sub 1 is equal to 5. So what does that mean? What piece of information did I just give you? A sub 1 is equal to 5. The first term is worth what? Is worth 5. Very good. Okay, now, and then I'm going to tell you that a sub n is equal to 3 times a sub n minus 1 and then plus 2. Whoa, what is all of this about? Okay? Here we go. Let's explain this to you. Let's say I have if this term is a sub n, what would the term right after it have to be? Very good. This term would be a sub n plus 1, right? What would the term right before it be? There you go, a sub n minus 1. So you have to realize, right, this piece of information matches exactly with that piece of information, right? So how do we create the first 4 terms out of this right here? How do we do it? Here's what we have to do, all right? The very first term they're telling us is the number 5. This is a sub 1. And they're telling us that's 5. It's defined that way. And I want the next couple of terms. I want a sub 2, and then I want a sub 3. Okay? How do I get the second term? Well, what this says is this, right? This part is the first term. We know that part. The a sub n is the definition of the sequence. This says 3 times the previous term and then add 2. So the way that I get this one is I would take this, 3 times the previous term, which is 5, and then add 2. What number would that give me? That would give me 15 plus 2, 17, right? So then I would have, so this term value is now worth 17. You guys see how that works? No? Okay. This right here, this information, this tells me that I'm taking 3 times the previous term and then I'm adding 2 in order to get the next term. That's what that tells me. Okay? So how would I get the third term? I would take 3 times the previous term. What's the previous term, you guys? 17, and then I would do what? I would add 2. Okay, if you don't have your calculators, you can use them right now. Figure out 3 times 17 and add 2. Very good. So you guys should have got 53 for that one. Let's go back to blue. 53. Good. What's the next term going to be? A sub 4. Well, it's going to be 3 times 53 plus 2. How much is that worth? 161. Okay. So this is an example of a recursion formula because we cannot produce the next term without knowing the one before it. Does that make sense to you? So I could not ask you, hey everybody, what's the 50th term, because we don't know which one. Which one do we not know? If we can't get the 50th. The 49th, thank you. We can't get it because we don't know the one before it. That's what recursion formula means. Okay, here you go. I'm telling you that the very first term, a sub 1 is equal to 3, and this is a recursive sequence. A sub n is defined as 2 times a sub n minus 1 plus 5. I want you to write out the first 5 terms. But remember, I already gave you one of them, right? The first term is what? It's 3. Okay, you guys write out the first, or the next 4. Ready, set, go. Okay, hopefully you guys all got the same thing I did. I walked around. Looks like most of us got the right answer. 3, 11, 27, 59, 123. Questions? All right, box number 5 is all about the factorial symbol. The exclamation point is the factorial symbol. The running joke in the math class is like it's not a really excited 5 if we were in English class, right? It's just, it means something else. So what does 5 factorial actually mean? Anybody know? Have we seen this before? Yeah, Justin.
Basically 5 times 4 times 3.
You're absolutely right. This means 5 times 4 times 3 times 2 times 1. Okay, that's what that means.
Like 27 factorial?
27 factorial is a very large number, man. Very, very large number. Yeah. Okay. So what would 6 factorial be? What does it mean? What does it mean? It means 6 times 5 times 4 times 3 times 2 times 1. Oh my gosh, right? Okay. Well, it turns out there's a button on your calculator, and it can do factorials, and I'm going to show you exactly where that button is. So I'm going to pull up my calculator. It looks like this. Pretty cool. Kind of cute. Okay. And isn't that nice? That's kind of nice, right? And it's not working. That's great. It's amazing. Okay, perfect. There we go. Go away. Come back. Work. Clear. There we go. Okay. So, with the way that this works for you guys, the button that's in red is the very last button that I touched. So if you happen to look down and I do something, you look up, you need to know that the red button is the last one that I've touched, okay? So how do I get the factorial symbol? Well, I want to do 5, so I'm going to push the button 5. And then I'm going to go into the math button. The math button is right there. The red one. Find the red one. And then look, you've got some math, number, complex, probability, or fraction. If you go all the way over to PRB, which stands for probability, so move the cursor over 3 times, you'll notice that option number 4 is a factorial symbol. Now you have two ways of activating that. You can either move your cursor down twice or 3 times to get down there, or you can just push option 4 and it creates the factorial symbol back there for you. Pretty sweet, right? Now we have 5 factorial in the calculator, and I hit the enter button, and I'm getting a value of 120. Okay? So I know 5 factorial is now worth 120. Okay, all right, so far so good. That's worth 120. Okay, everyone right now, please figure out 6 factorial in the calculator. Tell me what you get. Yep, I'm getting 720. Is that what you guys got too? Awesome. Okay, 720. Okay. That's equal to 720. Okay. So far, so good. So there's a couple of special cases here. What do you think 1 factorial is worth? What do you think it is? If you had to take a guess, what's your best guess? 1. You guys are saying 1. Okay, use the calculator. Tell me what it says. What? I did not get that, dude. If I go to probability and I go to option number 4, 1 factorial, I'm just getting a 1 out of this thing, okay? So 1 factorial is worth 1, okay? Here we go. 0 factorial. Before you use the calculator, what's your guess? What do you think it's going to be? 0? Okay. No solution? I hear 0, I hear no solution. Okay, use your calculators right now. Investigate. Tell me what 0 factorial is worth. You should have also realized that it is worth 1. What? Right? What? This doesn't make any sense. Okay, let me show you something really cool here, okay? We're trying to figure, I'm going to write down some numbers. 0, 1, 2, 3, 4, and then 5. Those are some numbers. And then below those numbers, I'm going to go ahead and write down what their factorials are, okay? So check this out. I know 1 factorial is 1. What's 2 factorial? Help me out.
2.
That's just 2. 3 factorial is 3 times 2 is 6. So 6. 4 factorial is 4 times 3 is 12. Times 2 is 24. Okay. 5 factorial, well, we just did that one, didn't we? That's 120. Okay. The big question of the day is, why is 0 factorial 1? I'm about to show you right now. So check this out. How much is 1 times 1? I mean, excuse me, I said something about circle something different. How much is 1 times 2? 2, good. Notice that that showed up right there. How much is 2 times 3? Notice that that showed up right there. How much is 6 times 4? Notice that that showed up right there. How about 24 and 5? Notice, okay, so the question we ask is, what number times 1 has to give us back a 1? It has to be. The only thing that can be is the number 1. Now, check this out. Here's something that's even cooler. Let's go the opposite direction. Let's put -1 here. Okay? So I'm trying to figure out this one, right? What number times 0 would give me a 1? It's not possible. So no solution. Therefore, factorial symbols only work for 0 and above, not 0 and below. Isn't that interesting? So here's the cool thing. If you check the calculator and you say, hey, calculator, what is -1? You put it in parentheses, and then you ask for the factorial symbol for the calculator, option number 4. Check it out. It's going to be very upset with you and say error domain, meaning that it's not possible. Okay? So I wanted to point that out to you. What do you guys suppose n factorial is? No, it's not infinity. Yeah, how do we write it? It's going to be n times what? N minus 1 times what? N minus 2 times what? N minus 3. Wait, how do I know when I stop?
You don't?
No, I do stop, right? Because I stopped with 5 factorial. I stopped with 6 factorial. What number do we always stop with?
0.
No, not 0.
1.
What? Yeah, 1, right? We go all the way down until we get to 1. So n factorial is defined as the number you're starting with, which n, times 1 less than that, times 2 less than that, times 3 less than that, until you get down to 1. All right?
How do you get down to 1 if you're
Okay. Here,
Oh,
check this
you
out.
have to-
Let's let n be 5. Okay? Now I'm just going to do this one for you, right? If n is 5, right? So this one will be 5, and then this is going to be 5 minus 1, and this is going to be 5 minus 2, and this is going to be 5 minus 3, And then eventually I get to 5 minus 4, and that's when I stop because that number is 1. So look, I have a 5, a 4, a 3, a 2, and a 1. People just aren't used to seeing it algebraically. Does that make sense? You with me on that part? Okay, we have to have some kind of understanding of the factorial symbol to write out some sequences that have factorials in them, like this one, for example. Write the first 4 terms of 2 to the n over n minus 1 factorial. Okay, well, we do the same exact process that we did before. So this is going to be 2 to the first all over 1 minus 1 factorial. Well, what's 2 to the first? 2. What's 1 minus 1? 0. What's 0 factorial? We just learned that one. So this is nothing more than 2 over 1. So my first term is worth 2. Okay? Let's do the second term. I want 2 squared, all divided by 2 minus 1 factorial. 2 squared is 4. 2 minus 1 is 1. And 1 factorial is 1. So the next term is 4. Okay, you and your partner finish off the last 2 for me. Awesome. So what do you guys get for the third term? 4. Also 4. What do you guys get for the fourth term? 8 over 3. What do you guys get for the fifth term? 4 thirds. Did you guys use your calculator for that or no? No? Okay, good. I like it. You guys are on board. Awesome. Okay, here's an example of something you might have to do, and that would be evaluating an expression. This says 10 factorial divided by 2 factorial times 8 factorial. Now, I see many of you grabbing the calculator, which is cool, but I want to talk with you about something else, right? What does 10 factorial actually mean? It means 10 times 9 times 8 factorial. What? Who sees it? Does anybody see what I'm saying? All divided by 2 factorial. Oh, and look, there's another 8 factorial down there. Who sees that cool trick? Raise your hand if you see it. Okay, let the record show almost everyone in the room sees the trick. I stopped. I rewrote 10 factorial because I know it's just 10 times 9 times 8 times 7 all the way down, right? But if I could be cool and realize that this right here is a fancy 1, right? Then they cancel out because they make a fraction of 1. So really, all I have is this. 10 times 9 divided by 2, since 2 factorial is just 2. And since 10 divided by 2 is the number 5, all of that is just worth 45, and we did it in no time at all. Pretty cool. All right, you guys, so let's do an abstract example now. How would I simplify the quantity n plus 1 factorial over n factorial? I see someone really excited. Okay, what do you got?
I got this.
Yeah, what do we do?
So it's n plus 1 times n
Yes.
factorial.
Oh my gosh.
And then you just cancel it out. And
Yes.
It's n plus 1.
Yes, you totally see it. Awesome. Okay, here we go. Let's try this one. What does the top literally mean? The top means this, right? It means n times what?
N minus
Times n minus 1 times what?
n minus
Times n minus 2 times what?
n minus 2.
N minus 3 all the way down until I get to what number?
1.
1. Good, that's what that means. Okay, now look. N minus 1. So I start with an n minus 1. What's the one after that going to be? No. N minus 2. What's the one after that going to be? And then all the way down until we get to what? Anybody see anything really nice that happens here? Look, all of that make a fancy 1. So all of this just simplifies to n. Okay, the last idea for the day is called summation notation. It sounds really weird, but basically what it means is, let's say I give you a sequence, okay? And I'm going to give you a sequence in blue. And the sequence is going to be 2, 4, 6, 8, and then 10. We'll stop there. Let's say I give you a finite sequence, okay? This right here is the first term. This, of course, is the second term. This, of course, is the third term, the fourth term, and, of course, the fifth term, right? Okay. Summation notation, notice that the word sum is right here. So what if I was interested in the sum of these terms here? There is a better way to write this, okay? And the way that you write a summation notation is you use the capital Greek letter sigma. Okay? So when you see this term, when you see this symbol, I want you to think of adding stuff up. Okay? Now, you need 3 pieces of information when you add stuff up. And all 3 pieces of the information are hidden inside the sigma notation. And they go like this. The information down below the sigma tells you where to start. Okay? The information on the top of the sigma tells you where to end. And then the information that is sitting out in front of sigma tells you exactly how you're supposed to do it. Okay, so how does this relate to the problem at hand here? So I am interested in adding up the sequence of 2, 4, 6, 8, 10. So here's the proper way that we would write this in sigma notation. I would first start off with my sigma notation. Okay, I would start with an n that's equal to 1, and I would end with an n that's equal to 5. And the way that I would do it would be 2n. What? That's crazy. So let me explain how this is working, what's going on here, okay? So check this out. N equals 1, that tells me that I start with the input of 1. 5 tells me that's where I stop with my last term at being 5. The 2n tells me how to generate the sequence. The summation means I'm adding them all up. Okay? So what my goal is that you are able to look at that piece of information and read it and understand what it means. So this means the sum of all terms from 1 to 5 of 2n. So that means plug in a 1 and you would generate the number 2, right? The first term is 2. Plug in a 2, what term would come out? A 4. Plug in a 3, what term would come out? A 6. Plug in a 4, what term would come out? 8. When do I stop? At the 5. That's the information at the top of the sigma. And then I plug 5, and I want to add all that up, right? So if I wanted to add all this up, let's just do this. 10 and 8 is 18. 18 and 6 is, help me out, 24. 24 and 4, 28. 30. So you guys, this is just a fancy way of writing the number 30. And that's called summation notation. Okay, here we go. I want us to be able to look at that and not be scared of it and read it and figure it out. So I want the sum of all I squareds plus 1s from 1 to 4. Okay? So how many terms am I going to have here? I'd have the first term plus the second term plus the third term plus the fourth term. You guys see that? Okay, how do I generate the first term? It's the same old trick, right? Plug it in. What's 1 squared? 1 plus 1 is what? 2. Good. What's 2 squared? Plus 1 is? Okay, this one is the same as the quick start, if you noticed. What's 3 squared? 9 plus 1? 10. What's 4 squared? 16 plus 1 is? And then I stop there because, look, I'm starting with 1, I'm ending with 4, and this is how I'm doing it. So what does that add up to? 20, how much? What'd you get? 34. So you guys, this is a fancy way of writing the number 34. Okay, this one is in reverse. It's kind of in reverse. I want you to write the summation. Okay? So n is starting with what? 1. Where is it ending, you guys? 7. Very good. And what are we doing to each n?
N cubed.
Yes, we are cubing it. So that is how we would write it. It's pretty cool, huh?